Okay. So, hello everyone. Um, Hello professors. So, over the past three assignments, I have moved from the foundational mechanic of individual classification model to the synergistic power of ensemble like batching or random forest. So, this short presentation isn't about re-explaining the homework step because I have explained it very carefully in my homework. I would rather to discuss the experience, the challenge, and the moment, as well as the knowledge I have gained from the homework of this week and the practical realization I gained by implementing this algorithm from the ground up. So my journey start with the core logic of decision tree in homework 14. Move to the probabilistic reasoning of 9 in homework 15. And culminated in building and comparing advanced uh, example methods like batching and random forest in homework 16. Okay, so now let's talk about some experience in homework 14 is the intuitive appeal of the decision trees. My first deep dive was with Hunt algorithm. The experience was incredibly insightful, but because decision tree was so visual and interpretable. So manually calculating entropy and generality is quite tedious, but very helpful to understand the core of this technique of this algorithm work. For each potential split, so I show exactly why a split on GBA smaller than 2.65 was chosen. It's created the purest possible tri-node, and you can literally trade the path of the decision here. I have manually calculated every single point to decide which node, which split is best that maximize information gain and split the maximize uh, Gini reduction. And I have also uh, learned some knowledge to deal with overfitting, like pre-pruning and post-pruning when I have to when I have like here when I have to choose the minimum sample per leaf, like mean sample leaf equal to 0. This means there's no split if the new leaf generation is smaller than 2 samples. It's helped me to dealing with the overfitting the weakness of the Hunt algorithms. And a shift to a probabilistic thinking with 90 bias, I implemented the 90 bias classifier, which require a completely different way of thinking compared to the iterative splitting of decision tree. 90 bias was much simpler to implement. The logic boiled down to counting frequency and applying Bayes' theorem. Uh, but actually, in this in the how in the homework, I have done two methods. I have done two ways when I consider the dataset is discrete data is a discrete value or a continuous value. I use discrete Navi bias to dealing with the frequent continuing the frequencies when I consider the dataset is discrete. And if I consider the dataset is continuous value. Yeah. So I used some Gaussian naive bias to dealing with this. So the core of the experience was grappling with the naive assumption of the feature independence. While working with the Pima Indian in diabetes dataset, which I will talk more in homework 15, I knew that features like glucose and BMI are likely correlated in reality. The model achieved around 75 accuracy on my test. Um, on the homework 16 here, when I practically implement the algorithms on the nine-based classifier, and algorithms, badging, random forest, everything I have learned in this, everything I have learned in this weekend, in this week. So the badging is for stability. So my first example was badging, the concept of the bootstrap aggregating, creating multiple tree from random subsample of the data was powerful. I could immediately see how this could solve the old fitting problem of a single disease tree by averaging the opinion uh like vote with the both that I have done in the previous homework. So the random forest is for robustness. The random forest took the step further in addition to bootstrap ensemble is also used a random subset for features or each split. So this was a key to a key realization. It prevent the model from relying too heavily on one or two dominant features like GBA in my homework 14 day data sets. So if I had to summarize my entire experience from homework 14 to homework 16, it could be this: there's no single best algorithm. The choice depends on the problem. However, for general purpose, the real world, application where performance and robustness are critical, I would now lean toward random forest. It strike an excellent balance. It's highly accurate, robust against overfitting, handle nonlinear data wealth, and doesn't require as much meticulous tuning as something like an SVM. That an algorithm is hard to explain and it's hard to understandable. Yeah. So this series of assignment provide a crucial hand-on understanding not just how this model work, but 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 how why I would choose one over another. So thank you for very thoughtful and carefully designed homework for us. It's very thoughtful for helpful for me and a person who has little uh, knowledge or experience with machine learning to understand the core, the uh, the main point, the primarily knowledge of the disease tree, like random forest, the core behind the algorithm. So thank you for uh, listening this presentation about the experience um, mm, of the uh, homework of this week from homework 14 to homework 16. I will end here. Goodbye. Stop recording.